In this video, I'm going to go a little bit more in depth discussing density. So recall that density is the mass to volume ratio. So the mathematical equation is that density equals mass over volume. So if I wanted to know what the unit was, it's called a derived unit because it's a mixture of two measured values. But we would just take what we do to the numbers, we would do to the units. So we would have mass on top, which we measure in grams. And then we have volume on bottom, which we measure in milliliters or centimeters cubed. So these two are the units that we see for density in chemistry, grams per milliliter or grams per centimeter cubed. Now, just so you remember, in your reference tables, there is a list of formulas on the second page. So density is the first one there, and it defines the variables here. So density is mass over volume. But also, density is a physical property, so it can be used to identify a substance or identify the purity of a substance. And recall that metals, there's a list of some metals on the front with the density here. Okay, and remember that centimeters cubed is equal to a milliliter. So I'm just going to do a couple of sample problems, and then I'm going to leave you with a little activity to do once you're finished watching this video. So let's say that we have an unknown metal, and it has a mass of 133.5 grams, and it has a volume of 15 milliliters, and we want to know what metal is it. So again, we can use density to identify a substance. So we're just going to take the mass of 133.5 grams and divide it by the volume of 15 milliliters. And if I plug that into my calculator, clear that out, 133.5, oops, divided by 15. Gives me 8.9 for my density. So that would be 8.9 grams per milliliter. And if I look at my reference table, I see that nickel, it has a density of 8.9. So the identity of that metal would be nickel. Now let's just do another type of example. So let's say we're given a metal and it looks like copper. However, it has a mass of 15 grams and it has a volume of 2 milliliters. And I want to know, is it copper? Oops. So I take my 15 grams, just like I did before, and divide it by my 2 milliliters. I don't need a calculator for this. And I get 7.5 grams per milliliter. Now, if I look at my reference table, I see copper has a mass, or a density, sorry, of 8.92 grams per centimeter cubed. So we would say, based on the fact that the density is much less, that no, this is not copper. Right? Now, I could also ask you then at that point, well, if this was a sample of copper, how much should it have actually weighed? Okay? So in that case, I would take, knowing the density, let me just write my equation one more time here. So the density of copper is 8.92. So what I would want to do is solve for, if I had a 2 milliliter sample, you know, what should the mass actually be? So I'm going to solve this equation for mass by taking density times volume. Okay, multiplying by volume on both sides. And I get D times V equals M. So 8.92 grams per milliliter. And if I multiply that by 2 milliliters, we can see that the milliliters cancel. And I would get, let's see, 8.92 times 2, 17.84 grams. So that's how much the sample of copper should have weighed if my little sample that I had was actually copper. Okay, so not only do we need to be able to calculate the density, but we also need to be able to algebraically rearrange those equations and solve for different variables. Now I'm going to leave you with a question, so and a little activity to do once you're done watching this video, and you can come get the supplies that you need from me, and once you finish your calculation, I just want to see what you did. So I have some pennies, and we learned when I did the nitric acid penny demo under the hood that at one point in time pennies changed from being pure copper to being copper, surrounding a zinc interior, because of the price of copper has gone up quite significantly, and therefore it doesn't make sense to make a penny out of pure copper anymore. So what I want you to do is I want you to take that penny, and I want you to determine the density of the penny by, as accurately as possible, measuring the mass and the volume, and determine whether or not you think that penny is pure copper or whether or not you think it's a copper and zinc mixture.